All right, let's get started with the third part of this review packet, the proving trig identities. So what I've done here is instead of writing cotangent squared theta, I wrote cosine squared over sine squared, and we know that that's true from this right here, except that's not squared, but you know, it's the same thing. All right, same thing here, cosecant squared theta. We know cosecant is equal to 1 over sine, so that's why cosecant squared theta is 1 over sine squared theta. And then similarly, we already wrote down cotangent squared theta, but we do it again. Now, we're going to work with the left side of the equation because that's the more complicated one. That's the way that I would recommend doing it. And so here, I'm going to multiply across the numerator. So cosine squared theta times 1 gives me cosine squared theta. And then a sine squared theta times a sine squared theta is really like saying x squared times x squared, which is x to the fourth. Or we can write this as sine to the fourth theta. And then I'm just going to drop down this minus cosine squared theta, sine squared theta. And in order for us to combine those fractions, I have to get a common denominator. And to do that, I would have to multiply the denominator here by sine squared theta. And by doing that, I'd have to multiply it by a fraction that's the same thing as 1. So now what that's going to be is I'm just going to drop this one down right here, and that's going to stay the same as cosine squared theta over sine to the fourth theta. But here on the numerator, I multiply across and I get cosine squared theta times sine squared theta. And multiplying across the denominators, I get sine to the fourth theta. Now I have a common denominator, so I can write and combine the numerators. So I'm just combining those. And then we've got the same denominator, so we're going to keep that as sine to the fourth theta. And I really should be every time writing cotangent to the fourth theta, cotangent to the fourth theta. All right. Now you might be able to notice here that we can pull out a common term. In this case, both terms, terms 1 and terms 2, have a cosine squared theta. So I'm going to pull out a cosine squared theta, and that's going to leave me with 1 minus sine squared theta all over sine to the fourth theta. Now, what is 1 minus sine squared theta? Well, if we go back to our Pythagorean identities and we rearrange this one, we subtract sine squared from both sides, we get cosine squared, cosine squared theta is equal to 1 minus sine squared theta. So this 1 minus sine squared theta is going to just change to be a cosine squared theta because they're the same thing. Again, drop down the cotangent to the fourth theta. Well, what's cosine squared times cosine squared? Well, that's just cosine to the fourth theta over sine to the fourth theta. Okay, and cosine over sine, we can look back up here. Cosine over sine is right here. That's going to be cotangent, but since we're to the fourth power, this is going to be cotangent to the fourth theta. Oh, equals cotangent to the fourth theta. That's exciting. We got a match. All right, let's try the next one here. Like I did on the last one, our first thing is really to rewrite each of these as with sine and cosine. And we're going to keep the cotangent just as it is, and hopefully we'll turn into that at the end. So tangent, let's start with the tangent first. That's going to be sine over cosine. All right, and then let's go to cosecant squared. That's going to be 1 over sine squared theta. Minus tangent theta is going to be sine theta over cosine theta. I'm just going to keep that cotangent theta on the right. All right, next thing I'd like to do is multiply these right here. So multiplying across the numerators, I get sine theta over cosine theta sine squared theta minus sine theta over cosine theta equals cotangent theta. And what happens if I have a sine theta in the numerator and a sine squared theta in the denominator? Well, if you're kind of confused about why I can cross that out on the answer key, basically what I have is a sine theta over cosine theta times sine theta times sine theta, right? Because sine squared theta is the same thing as sine times sine. So let me just rewrite the rest of this and then we can do our next step. So our sine thetas are going to cancel, and I'm left with 1 over cosine theta times sine theta minus sine theta over cosine theta equals cotangent theta. And I'm guessing you probably understand what's next. We're trying to get a common denominator so we can combine these fractions. So we're going to multiply by sine theta over sine theta. So that's going to give me, this doesn't change over here. But over here, I'm left with the sine squared theta over cosine theta sine theta. And rewrite this cotangent theta. Now we have a common denominator, so I can rewrite this as 1 minus sine squared theta over cosine theta sine theta. Oops, why did I do that? Silly goose. And 1 minus sine squared theta, we already talked about this up here, is just subtract the sine squared to the other side, and that's going to give you cosine squared theta. So this is cosine squared theta over cosine theta sine theta. Okay, well, of the cosine squared theta, we can really think about that as cosine theta times cosine theta, and you don't have to write that if you kind of feel like you understand it, and you can just cancel one of them out. But just for me explaining it to you, just know that cosine squared theta is cosine times cosine, which means that we can cancel out a cosine and a cosine. So we're left with cosine theta over sine theta equals cotangent theta. And I've literally gotten the definition, so cotangent is cosine over sine, so I can rewrite this as cotangent theta equals cotangent theta. And we're good to go there. I really enjoy these. I know that this is a huge jump for you because we're proving mathematical things to be true. But there are, you know, kind of some commonalities of what you do every time in terms of rewriting sine and cosine. All right, so just like I said, we need to rewrite these as sine and cosine. So secant theta is going to be 1 over cosine. And we're still dividing it by sine theta minus sine theta, and I'm just going to keep it just like that, over cosine theta. And since the right side is way more simple, we're going to just keep that the same the whole time. All right, the trick on this one is to reduce this fraction, and we know that when we divide by something, we can multiply by its reciprocal. So I'm going to keep the 1 over cosine theta, but when I'm dividing by sine theta, that's the same thing as multiplying by 1 over sine theta. All right. So now I'm going to multiply this fraction right here, and that's going to give me 1 times 1 is 1, and then I'm going to have cosine theta sine theta. And then you probably guessed right here, we have to combine these fractions, and to do so, I need to make sure they have a common denominator. So I want to try to get this denominator, which is why I would multiply by sine over sine. Okay, so that's going to give me 1, and this doesn't change over here. This is the same thing. But on the right side, I now have a sine squared theta over cosine theta sine theta. So now I can combine these fractions. So this is going to give me 1 minus sine squared theta over cosine theta sine theta. Looks like I forgot to write my equals cotangent theta. Okay, and I feel like we've gotten kind of the hang of this, that 1 minus sine squared theta is going to give us cosine squared theta right here. So we have cosine squared theta over cosine theta sine theta. And then cosine squared theta, we can rewrite that as cosine times cosine. So that would be cosine theta times cosine theta over cosine theta sine theta. Okay, my cosines cancel. So I'm left with a cosine theta over sine theta equals cotangent theta, and we absolutely know that that's true. If we look up here, we know that cotangent is cosine over sine. So this is going to give me cotangent theta equals cotangent theta. Are you social distancing? Why, yes, I am. I hope you guys have a great day. Thanks for listening. I appreciate that so much. Take care.